Hi everyone. Good afternoon. Am I audible? Can anyone respond, please? Okay. Thanks for the response. Let's wait for like 4 minutes more. We'll start sharp at 3:05. There might be people who are joining still. Let's wait for this 3 minutes. No, it's 3:02. We'll start at 3:05. Thank you. Okay, let's start with our session today. So welcome guys, welcome to the second session of this program, FDP program for faculty development. We will be starting on with some of the core concepts of data science today. Yesterday we had an introduction class. We tried to figure out the high level overview of what data science is, what kind of problem statements that we usually try to solve, what is the data science life cycle and components and all that stuff, right? So we covered all of those things in yesterday's class. In continuation to that, we will start with basics of statistics today, because to do any analysis with the data, statistics is one of the very important aspect, I would say, important component that you all have to know. So we will just try to touch upon some very basic statistic terminology, which we all know, but I just want to just brush upon those things. And then we'll move a little bit more further into the data, types of data. And then we will try to understand what is machine learning. And then we'll try to understand what is supervised machine learning, what is unsupervised machine learning. And then we'll get into an actual algorithm today, which is called as linear regression. We will try to implement that also in Python, right? So as I said, there is an echo in my voice. Is it same for everybody? Or is it only for Ramesh? Clear. Dr. Murli says it's clear. Dipanvita says it's clear. Ramesh, can you please check your speaker once? Probably it might be an issue there. Yeah, thanks. Thanks a lot for the response, guys. So those are the things that we are going to look in for today's class, basically. Let me share my screen and then continue. Is my screen visible? Yeah. So let me just a moment. Give me a second. Just go here in a presentation mode and then. Yes. So these are the things that we are going to cover today: basics of statistics, then introduction to machine learning, which is ML, and then what is supervised machine learning, what is unsupervised learning, what is linear regression. We'll try to do all of these things and then try to touch upon some of the use cases. And then we'll try to implement this linear regression on Python code as well, right? So for everybody's information, I have already shared the PPT and also the data set that I'm going to use in today's class in LMS. Like how Leela explained in yesterday's class, how to download that data from LMS. You all know probably, right? So if you have some time, just go there and download it. And then by the end of the day, I'll also give you some of the sources where you can find some of relevant data sets, which you can download and do the practice from your end as well. Right. So let's get into the content. So the today's agenda, as I said, it will start with the data types, right? So we will try to understand what are data types. Before that, we'll try to just define what is statistics, what are the important concepts of statistics, and what is inferential statistics, descriptive statistics, and all that. And then we'll get into what are data types, in which we'll talk about numerical data type and we'll talk about categorical data type. Then we will get into introduction of machine learning. What does actual book definition of machine learning is? And apart from that, we'll try to just talk in terms of normal language. We'll try to understand how this can be understood in much more subtle way, right? Apart from that, we'll try to understand what is supervised machine learning, unsupervised machine learning, and then we'll try to understand what are the types of problems that we usually handle in machine learning. And in that, basically, we'll look into the specific sect, which is classification and regression problems. And then we'll implement a simple multiple linear regression in Python. We'll try to do some coding as well in today's class, right? So these are all the things. I know agenda is pretty heavy for today. Just stay with me, guys. I'll try to explain as much as possible wherever there is an explanation required. And then I'll be concentrating a little bit more on the practical side than the theoretical aspect of it, right? So I'll try to build some basic building blocks, and then we'll try to implement all of these things and try to analyze the results and see how it looks like. So let's get into what statistics is, right? So whenever we talk about statistics, we usually have a notion, or we usually have a definition in our minds that statistics is just numbers, right? So whenever we say that, okay, I want statistics of some data that we are having, we only think that it might be some numbers, right? Like what we see in our maybe a cricket match, for example, right? So what is the statistics of the match that we are watching, right? So it might be, we always tend to understand that it might be just some numbers, but statistics, it's not just numbers, right? So it includes all of these points over here, which we see, right? So it's collecting the data, it's classifying the data, summarizing the data, analyzing the data, and interpreting numerical information in the data, right? So it includes all of these things, right? So it's a science of data, basically, which includes all these steps, right? So collecting the data, it might be multiple instruments that you might have to collect the data. You might go to people and ask them to fill some forms. That is one way of collecting data. You might give some digital forms for them and ask them to fill it before getting in something. That is also one way of collecting the data. You might you might actually send in some sort of surveys where people give their opinions with their details. That is also one way of actually collecting the data, right? So you can see that the data collection may be multiple ways, right? So that is one point that we all have to remember, right? So that is one very, very important aspect also, right? So targeting the specific audience for specific data becomes very, very important, right? So it also depends on what problem statement and what kind of data that you want, and what is the audience that you are actually asking the data for, right? So you might not want to just ask some random people about something which you need specific, right? So these are all the steps, or these are all the things that probably becomes very, very important, right? So then classifying the data, right? So trying to understand what kind of data types that you are having, right? Summarizing the data, trying to do some sort of analysis on your data itself and try to summarize the data, right? So analysis of the data and interpreting numerical information in the data. So all of these steps together, we call something called as statistics, right? So statistics is used in several different disciplines, both scientific and non-scientific, to make decisions and draw conclusions based on data, right? So now you can see that statistics is not only limited to any domain as such, right? So it can be used in medical domain, it can be used in education domain, it can be used in retail domain. Everywhere, wherever you have data, the statistics concept will come into picture, and that's the reason it's very, very important for all of us to understand at least the basics of statistics, to make sure that we understand the data properly. Right? So that's the high level understanding of statistics, right? So it is collection, classification, summarization, analysis, and also trying to interpret the data. These all steps together, we call it as statistics, right? So when we move ahead a little bit more into statistics, we encounter some of the terminologies, right? So now you can see that there is something called as sample and there is something called as population. Right. So now, given a problem statement that I am working on, you usually use these kinds of terminology, which is a sample data or maybe a population data. Right. So population data is basically a hypothetical set of n observations from which the sample is obtained. Right. So it might be the complete data or the people of interest or the number of records that you are interested in, basically, which are pertaining to your problem statement. Let's say that I am actually interested in trying to understand the salaries of people who are working in Hyderabad, right? So now the population for me becomes the whole population of Hyderabad. Similarly, if I am interested in trying to understand, for example, I'm actually working on some sort of a mechanical domain. Let's say that there is some nut bolt company or a bolt company which is actually manufacturing bolts, right? So if I am interested in how many number of bolts that are actually in certain range of diameter or maybe of length, then the population of that interest, for my interest, it becomes that the whole number of bolts that they have actually generated or they have manufactured, right? So basically the complete set of data which is available, probably which we are interested in, that becomes the population, right? So for the population also, there would be some parameters that which we want to understand. The first parameter is maybe the mean, and then variance and standard deviations, right? So these are all the things which we already know, right? So mean is nothing but an average. Variance is basically trying to tell me how the data is spread across the mean, right? So standard deviation is trying to give units to your variance itself, right? So these are all the parameters which I want to know about the data, which helps me to understand the data in a better way, right? So that is the parameters of your population for now, right? So similarly, we also have a concept of sample, right? So trying to work on population in each and every problem statement is very, very hard for us, right? So usually there are a lot of constraints if I say that I want the complete population, right? So now in such cases, what we do is we go to the concept called as sample. Now sample is nothing but a subset of data which is probably randomly distributed inside the population. I'm just going to pick up some number of records in a population randomly, and I can call that as a sample, right? So the definition here says that a sample is a set of n observations actually obtained and a statistic in a numerical value that describes the sample, right? So the number of records which I'm actually pulling out from the population itself is called as sample, right? So most of the times I will be working on sample because there will be a lot of constraint to completely get the population in our hands, for example, right? So now I might not be able to handle so much of data. If I have like millions and millions of records, probably I don't have enough compute to completely work on the population. Or maybe even if I have so much of compute, maybe I don't have so much of time, right? So in such cases, what we usually do is we work on sample and then try to infer the results that we are having on sample to population, right? So the parameter here in sample also are similar to the parameters that we have in our population, right? So basically there is something called a sample mean, sample variance, sample standard deviation, whatever the things that we calculate on our samples, we call it as a sample parameters, right? So once we have the sample parameters, we try to infer those parameters to population, which we have not done, right? So here comes the concept of your inferential statistics, where what we usually say in definition is we try to do some analysis on our sample and try to infer those results to the complete population. But there would be some tests here, right? So we will try to do some tests. We will try to do it methodologically and then say that, okay, this is somewhere near to the population parameters that we have, right? So moving forward, do we have any questions over here? Okay. Looks like things are clear up till here, right? So now this is the concept of sample and population, right? So it becomes very, very important because these are all kinds of basic steps or basic concepts that we want to know before trying to actually get into the data, right? So once we understand this sample and population, what we usually do is we try to understand these two types of, or these two sections in statistics. One, we call it as a descriptive statistics. The other one, we call it as inferential statistics, right? So to talk in a very simple words, descriptive statistics is nothing but when we have the whole data, or we assume the data that we are having as a population, and then we do all the analysis on the data and get conclusions about the data there itself. Right? So this is what your descriptive statistics mean, right? So assuming whatever the data that we are having is the final data, right? And then trying to get all the analysis and all the numbers that we want, and assuming that that is the end of it, right? So that is something called as descriptive statistics, right? So definition, what it says, descriptive statistics utilize numerical and graphical methods to look for patterns in the data set, to summarize the information revealed in the data set, and to present the information in a convenient form, and individuals can use to make decisions, right? So at the end of the day, these are all the parameters which help me to make decisions from my data. So these are all called as data-driven decisions at the end of the day. But identifying or assuming that the data that I am having is the whole and trying to work on the whole data is called as descriptive statistics, right? So the next concept that which we usually talk about is called as inferential statistics. Right. So as I said, inferential statistics includes your topic of sample and population. Right. So when I don't have enough instruments or enough facilities with me to work on the whole population, what I would do, I would actually work on a sample of data, because sample of data would be less number of data points. Right. So maybe I have like 1 billion records with me. It's not advised to work on 1 billion records at once. Probably your system might not be able to handle it, or maybe there is a lot of time that it's going to take, or it might take a lot of effort from you to clean the data. There might be n number of logistic problems that you will face. Right. So hence what we do is we get into this concept of sampling. I will say that, okay, let me sample 1 lakh of 1 billion. Or maybe 10,000 of 1 billion, right? So again, you are going to set up, or you are going to come up with whatever the sample size that you want to pull out from the population. And now once you do the sampling from the population, now we assume that whatever the distribution that the complete population was following, the same distribution will be followed even by our sample, because we have picked randomly. We are not adding any biases in our data while we are picking it up, right? So now that gives me confidence, and that says that, okay, if I take enough number of samples, that should be a representative of our whole population. And then let me work on my sample itself, and then try to infer whatever the results that I have got from my sample to the population itself, right? So the definition here says inferential statistics utilizes sample data to make estimates, decisions, predictions, or other generalization about larger set of data. Some examples of inferential statistics might be a Z statistic or a T statistic. So these are all the tests that we usually do to identify whether we are actually picked up the right sample or not, and then how much tolerance or how much confidence interval we call it as, right? So in are we there in that range or not? There are multiple tests that we want to follow. We also do something called as hypothesis testing at one point of a time. But at the end of the day, this all comes under something called as inferential statistics, right? So do we have any questions here? In understanding what is descriptive and what is inferential statistics? Okay. So this was kind of a very high level introduction to what statistics is, what are the concept of statistics, or what do we actually try to do using the statistics and all, right? So now let's get into something called as, oh yeah, this is already done, inferential statistics. The main goal of inferential statistics is to come to a conclusion of population. This is all fine. Yeah. So the next thing that we want to understand is data types itself, right? So now what does a data type mean? That is very, very important, right? So you might see data in different types of formats, right? So I'm not talking about formats in the sense of file extensions here. It might be a CSV, it might be an Excel. I'm not talking about that right now. I'm only trying to mention that data when we are talking in terms of columns over here, right? So those columns might be of different data types. It might be of an integer type, it might be of a float type, or it might be of your categorical type, string type, whatever it might be, right? So now we need to make sure that we have understood our data properly, so that while we want to do some basic analysis on the data, we are not going wrong anywhere, right? So now what are the types of data that we usually look into, right? So usually when we talk about this data, we have broadly two types, or we divide, or just a moment. Yeah. So we divide our data into two types. Let me add, yeah. So this is a white page over here. Let me write something. Right. So when we call data, basically about columns, right? So data, we usually broadly segregate them or categorize them into something called as numerical and categorical, right? So any data which can be seen in terms of numbers, we call that as numerical data on a high level, right? So when it comes to categorical data, these are not numbers, these are all categories, right? So these are all levels you can call, right? So when I say examples for a numerical attribute, it might be age column can be numerical, right? So maybe salary column can be numerical, right? So maybe something else, right? So bank balance, this can be numerical, right? So you can see that all of these variables will contain numbers in it, right? So these are all falling under something called as numerical attributes. And when we talk about categorical attributes, basically these are all levels, or these are all categories, right? So for example, country column, right? Or maybe some sort of rank column, maybe reviews column, review system, right? So 1 star, 2 star, 3 star, and so on and so forth, right? So, or maybe color, red, blue, green, and so on and so forth. So that it might indicate something or it might not indicate something, but you have those as column, those things as columns basically, right? So these types of columns, we call them as categorical attributes. And when we have pure numbers in our column, we call it as numerical attributes, right? So even in our numerical attributes, we again divide them into two sets. One, we call something as continuous. And then we have one more thing, which is called as discrete. In categorical also, we have two things again, something which is called as ordinal, and one more which is called as nominal, right? So now in this further, what you call distinction in numerical itself, can anybody give me an example or can anybody tell me what a continuous attribute means? Anyone? Share market data, sequential, age, right? Vipul, sequential, I did not understand what you wanted to say, but Dr. Jagdish says age, that's correct. Share market data, Dr. Brahma says that's also correct. Any other examples? Time, yes, that's true. Dr. Murli, that's perfect. Time is continuous. What else? Weather data can be, house prices can be, time series data can be. Voltage data can be, yeah. So all of these things which you guys are mentioning in the chat boxes are all continuous data itself, right? So temperature can be continuous, yes. So any of the data or any of the column which follows a continuous distribution, that means which can have basically decimals in it, right? So I can't specify on a certain point and call it end there. Like, so for example, length, right? So how do we measure something as a length, right? So it might be in meters, for example, right? So when I say 1 meter, is it exactly 1 meter? It can be 1.0000001 meter, or it can be 0.99999 a meter, right? So now you can see that there can be this is how a continuous distribution is actually defined, right? So we can't actually say at a probability of a certain point cannot be calculated. It can only be calculated with certain range. I can say probability of a certain person's height between maybe 5 feet 10 inches to 6 feet is something, right? So I can't say what is the probability of a person who is exactly 5 feet 10 inches, because that is not possible. It can be very, very near to 5 feet 10, or it can be a little bit more than 5 feet 10, right? So it's very, very hard for us to measure that exact point, right? So now these kind of variables, which becomes very, very hard and follow a continuous distribution, we call them as continuous attributes. All of those examples that everybody mentioned over here, right? So temperature, we can't, it's actually measuring, right? So voltage data, time series data, house prices, all of them basically follow this continuous distribution, and hence we call them as continuous attributes, right? Similarly, can anybody come up with examples of discrete attributes? But before that, is it understood now for everyone what continuous attribute means? Number of items discrete, right? So this is number of people in the class. Awesome. These are all the examples which are discrete, right? So basically now when I see the number of participants who have joined this class is 839, or now it's fluctuating a little bit. Let's say that 843, right? So I have a specific discrete number here saying that there are 843 people who have joined this class. This becomes discrete, right? So on a high level, what I can say this as number of participants. Right? So it can't be 843.5 or it can't be 843.8 and so on and so forth. Right? It's a discrete number because we are actually trying to mention people. Similarly, I can say that what is the parking space that you have? How many number of cars that you can fit in a parking space? Right? So now you can say that we are trying to measure the number of cars there. Hence, I would say that that can also become a discrete. Right? So similar examples you can talk about number of accident. Right? So whenever we don't have a fraction point, basically we call that as a discrete attribute. So countable and specific number. Correct, Madhav? All of these things are right over here. Right? So which can be measured exactly and it follows a discrete distribution. We call them as discrete attributes, which comes under numerical attributes again. Right? So any questions in this part of explanation or concept? Dr. Rahul, I'm not really sure if ECG data can be called as discrete. Maybe we need to check on that because it's the voltage that we are measuring, right? Per second or maybe per millisecond. I'm not really sure, but probably we need to recheck on it if we are talking about discrete data. Yeah. So any questions or any doubts on this wing about numerical data? Awesome. Let's get into the next part, which is called as categorical attribute. Right. So as I said, categorical attributes, you will have levels or you will have categories in your data, and examples being this, right? So color, your rank, review, and so on and so forth. But even in categorical attribute, there are two things again, which is called as ordinal, and one more thing is called as nominal. Right. So now can anybody give me any example for what ordinal means? The data which is in order is called ordinal data. That's true. First rank, correct. First class, second, right. So now, if we want to explain this properly, how would we say? We say that when I have a relative comparison between the levels in the category, then I can call it as ordinal data. Right. So for example, let's say rank. Right. So let's talk about ranks in maybe defense or maybe in military. Right. So I hope everybody understands these ranks in military. Right. So there might be somebody who is a major. Right. So maybe there is somebody who is a brigadier. Right. So somebody who is a colonel. Right. So now you can see that these being categories, but there would be a comparison that I can do between these ranks. Right. So probably brigade in these three, probably brigadier is the highest rank, and then probably colonel is the next highest rank, and then maybe major is the next highest rank. Right. So here you have levels that can be compared with. Right. So for example, some review system. Right. So maybe if I say that there is a movie which is of 5 stars. Right. And there is also a movie which is of 3 stars. Right. So now, can I say that a 5-star movie is better than 3-star movie? Can I do a comparison based on the stars that I'm having? Right. So now when I can do this kinds of relative comparison between the levels, we call it as ordinal data. That means there is certain order in the categories that we are having. Right. So yes, somebody said low, middle, high. Right. So now if I'm actually mentioning income level or maybe income categories, right? So there might be a low income category, medium income category, and a high income category. There exists a order between these three. I can compare between these three categories. These kinds of variables in categorical are called as ordinal. Right. So now this was something about ordinal data. But now there is also something called as nominal data. What does nominal data mean? Male, female, white, black, true, false. Correct. It has no orders, true or false type. Yeah. So everybody is correct over here, right? So anything which doesn't have an order, right? So for example, I have red, green, blue. These are the colors that I have in my category. Now, can I compare between these three categories? There is no way that I can compare, right? For example, there are some cities, let's say Hyderabad, Bangalore, and maybe Mumbai. Without any context, I'll not be able to compare between these three cities, right? So these kind of variables where there is no order present, that is called as nominal data. Similarly, there might be male and female, no order, right? So these are two categories, but there is no comparison between these two categories, like your color or like your countries, or for example, like the gender, right? So these are the types of categories which fall under something called as nominal categories. Are we all clear now? What is the difference between numerical attribute and categorical attribute? And inside numerical, what is continuous and discrete? And in categorical, what is ordinal and nominal? Are we all clear? Yeah, awesome. So let me just clear all the things that I have written. Right, so this is the first step that I want to do, or I want to understand before actually getting into the actual data, right? So I want to understand what kind of data types that I have, right? So that helps me to understand my data and take better decisions about my data, right? So you can see all of those things which are over here. There is also something called as ratios that people usually talk about. I'm not getting into that right now. We will talk about it when it is required. But on a high level, these are the things that you want to remember, right? So Sheshadri, Dr. Sheshadri, sir, you said you want examples for continuous attributes. Yeah. So as I said, anything which can be measured and which cannot be discrete in nature can be your continuous attribute, right? Like what I said was height of the person, weight of the person, right? Or maybe what else? Some voltage, right? So all of these things come under your continuous attributes, right? So which has certain decimals, or which you cannot actually mention, measure it to exact discrete type, right? So all of those things come under your continuous variable type. So we have some of the examples over here. Let me just talk about it, right? So now if you see here, can anybody tell me now, first one, it is time, whether this is continuous or numerical, discrete? Continuous. Everybody is saying continuous, right? So basically this can be a continuous distribution, right? So all of these things, right? So your time actually will come under something called as continuous attribute. Similarly, there is money. Money continuous or discrete? Discrete, right? So all this you can actually measure, or you can actually say that, okay, this much number of, this is the amount of rupees or dollars or whatever you say, right? So all of these come under something called as your discrete, right? So next there is measurement scale, that you can see there is a ruler, right? So this again becomes continuous. And then there is number of laptops that has been stacked on. You can see 4 laptops, right? So now it can't be 4.5 laptops or 3.4 laptops. You can't say that, right? So these comes under something called as discrete. Similarly, number of cars, you can see that this is also discrete, right? So this was the concept of your continuous and discrete attributes in your numerical column, right? Yeah, so this is again one small test kind of stuff. Volume of a cereal box, what can this be? This is discrete or continuous? Volume, think again. People are saying this is discrete, but I have a different opinion. Volume is measured in basically your cubes, right? Meter cube, centimeter cube, right? So it can be a continuous, measurable. right? How about speed of a car? Continuous, right? So again, population of a town. Right, so again discrete. So number of shirt is again discrete. And then what else do we have? Length of crocodile, it's again going to be continuous, right? So number of goals in a season, discrete. Temperature of an oven, again continuous. Number of matches in a box, again it's discrete, right? So this is how you do the comparison between what is actually a continuous attribute and a discrete attribute, right? So I hope the things are clear now. Yeah. So the next thing is basically we talk about one more concept, which is called as central tendencies, right? So whenever we have any data, it's very, very important for us to understand these central tendencies, right? So here the name looks pretty complicated. We might see that, okay, what does the central tendencies mean and everything? Central tendencies is nothing but your mean, median, and mode, right? So these are all the things which we have probably learned in our schools. Right, so mean is nothing but your average, saying that how can I measure it? Basically, your summation of your xi by n, right? So based on the total number of variables you are having or the total number of rows you are having, you just want to calculate the average of it, right? So for example, if I have some variable, let's say some variable called as age, right? So let's say that is 22, maybe 23, maybe 25, and maybe 26, right? So how would I calculate mean? It's just 22 plus 23 plus 25 plus 26 divided by 4. Basically, this becomes your mean, right? So how do I calculate median? Can anybody tell me? (23 plus 25 by 2). 23 plus 25 by 2, correct? Middlemost value, that's true, right? So let's say that I have a different example. Let's say I have age again, maybe 22, maybe 28, maybe 19, maybe 36, maybe 40, right? So in this, what is my median? People are saying 19 is the median. Some people are saying 28 is the median. So the first step that you always do while you are calculating median or while you're trying to find out your median is sort your data, right? So once you sort your data, how does your data will look like? Basically 19, 22, 28, 36, and 40, right? So 28 is the middle value. This becomes your median, right? So the first step people always have to remember is while we are calculating medians, you'll have to sort your data. That's the important step that we all have to remember, right? So apart from that, there is one more parameter that we all want to understand, which is something called as mode, right? So what does mode mean? Mode is basically a most frequent value. Here you can see that there is no mode, right? So whenever the value is repeating and whichever the value has repeated most number of times, then that is called as mode. Usually it helps in your categorical data, right? So all of these three things will help you while you are dealing with your missing values, right? So if there is some data point which is missing, for example, this is not missing, this is not there with me, then what I would do is maybe I'll calculate mean of these 4 values and then impute my data here. This is called as imputation of the data, right? If I have an outlier problem, what would I do? I will go with median and then do an imputation there. Right? So why median in case of outliers? Because you might have an outlier. So for example, there might be a 0 over here. There might be a 10 lakh at the end, right? These 2 outliers will not affect your median. That means the representation of the data will remain same. Hence, you will go with median sometimes when you are sure that you don't have any outliers in your data. But usually you go with mean when you know that you don't have any outliers in your data. right? But if it is some sort of a categorical attribute and then it is missing, you can't calculate mean and median for categorical data. Hence, what you do is you go with mode and then impute it, right? So this is how you deal with missing data as well when you know what is mean, median, and mode of the data. Is this understood? Yeah. So let me clear this up. So now this was a high level overview, or I would say just a quick introduction to the statistics and terminologies that we use in our statistics, right? So now from this is all the calculation part, which I already went through, right? So you can see that calculation of mean is pretty simple. Just take all the values and just do an addition of it and divide by the number of values that you are having. That is going to give you an average of it, which we call it as mean. And then median, as I said, the first thing that we want to do is we want to just sort the value in our ascending order and then pick the middle value. And if the number of values are actually even, what you do, you just pick two center values and take average of those two values. That is how you calculate median on your data. Right? And then there is mode. You can see that mode is basically trying to calculate or trying to find out which is a value which is most frequent. And so in this, I can see that 6 has occurred 3 times. So probably 6 is your mode, right? So there might be bimodal, but there might be multimodal data with you as well, right? So you can have those kinds of scenarios while you're working on the data. So yeah, so that was about a very, very quick or a small short introduction about your statistics, right? So before we get into the machine learning part, do we have any questions or any doubts that you want me to clear? About statistics, or maybe about the types of data that we dealt, or about the central tendencies? For standard deviation, also used it. Dr. Jagdish, can you specify or elaborate this? So standard deviation, I mean, are you asking or are you making a statement? I did not understand, sorry. Okay, so for mean calculation, results similar to standard deviation results. Yeah, so usually what happens is we do have these parameters, which is again standard deviation, or it actually starts with variance, right? So it actually tells us how our data is distributed, right? And then from our variance, we also calculate standard deviation, right? So yeah, dispersion of your data, basically, that is also being calculated. I've not just included those things because again, our sessions would become very, very lengthy. I have a lot of things to cover, but whatever the things that we have covered so far, that should be enough. If you want to get into variance and standard deviation, I would recommend you to read things about it. That's also helpful, I would say, right? But again, standard deviation and variance are two parameters to understand your data in a better way, right? So the whatever Dr. Jagdish is saying, that is correct, and also what Madhav is saying, that is also correct, right? So that's true. We need to understand those two parameters also. Apart from this, any other questions, any doubts, guys, before we move forward? Okay, so now let's get into the machine learning part of it, right? So here starts the things that we actually want to do on our data, right? So now, can anybody tell me like what kind of representation of what kind of diagram is this on the screen? Yeah, right. So this is actually a Venn diagram, right? So it's not a pie chart, it's basically a Venn diagram, right? So now if you can see that what we are trying to do is we are trying to find out the importances, or you can say the scope of each and every terminologies that we are going to discuss about, right? So now if you see here, there is something called as data science, right? So this data science is covering all the aspects that we are going to work or that we are going to learn, right? So inside that data science, there is a big subset which is called as AI or artificial intelligence. And in AI, there is one more subset which is called as machine learning. And inside machine learning, there is one more subset which is called as deep learning, right? So now this data science, as you can see over here, this consists of all of these three. Apart from this, it also has all your other concepts also, right? So there will be an overlapping of your statistics. There will be overlapping of visualizations in your data set, data science, right? So visualizations which include all your charts, like your scatter plot, your pie chart, or maybe your bar graph, or your other pair plots and all those things, right? So all of these things with your statistics and maybe a little bit of math concepts, all of these will come under data science with AI, ML, and deep learning, right? So now given that as the background, now let's try to understand what actually is this AI, right? So now AI, as you can see, now before me defining this terminology, can anybody tell me what do you think, or give me some application that you think of when we talk about AI? Anyone? One application that you think about when you talk about AI? ChatGPT, Google Assistant, Lyft, I'm not sure, chatbots, okay, robotics, awesome. So have you all heard about, yeah, Alexa is also a correct this thing. Have you all heard about this? Excuse me, sorry. Have you heard about this? Autonomous cars? Right, so this is an ideal example of how your AI should look like, right? So when we talk about AI, it's not about only one or two tasks which it is doing simultaneously, right? So AI is something which is capable of doing multiple tasks at once, right? So you can see that when you talk about an autonomous car or a self-driving car, it needs to understand so many things before it actually puts any action in play, right? So you can see that it has to understand how would I actually go from point A to point B, right? So for this also there would be multiple constraints, right? So you can say that there is something called as optimization, that is which is the shortest path that I need to go from A to B, which is the safest path that I need to take if I want to go from A to B, right? So which is the less time consuming path that I need to take if I have to go from A to B, right? So you can see that so many constraints that are coming in. Apart from this, there can be also, it also has to understand how a road looks, right? So how much speed it has to drive in, right? So are there any people in front of it? Is there any car in front of it? If there is a car, is it going fast? Is it going slow? Can I overtake it? Can I not overtake it? Right? Do I have to stop somewhere? What if I have to do, there is something which is kind of an anomaly that is happening in my drive, right? So now you can just imagine so many things that it has to calculate, it has to predict, it has to estimate and take decisions simultaneously, right? So when we talk about these kinds of concepts, or when we talk about these kinds of application, those come under something called as artificial intelligence, right? So somebody rightly said of your ChatGPT, right? So ChatGPT is not just a very naive or a very what you would say simple application and algorithm, right? So ask any question, it tries to give an answer. It might be code, it might be a question, it might be related to general knowledge. It covers so many things in it, right? So again, when we talk about a specific chatbots, maybe it's not complete AI, maybe a little bit of things that have been added in it. But when it comes to ChatGPT, it's specifically, it's going to be coming in AI, right? So these kinds of applications or these kinds of concepts, all of those come under something called as artificial intelligence, right? And in this artificial intelligence, there are a specific set of problems which can be solved, and they come under something called as machine learning, right? So what does machine learning mean, or what kind of problem statements does this machine learning actually cover, right? So we will talk about that also today, right? So once we understand what kind of problems that machine learning actually tackles, what we do is we try to understand deep learning. Deep learning is again a smaller subset inside machine learning, which tries to address some sort of more complex problems than machine learning problems, right? So does this Venn diagram and the explanation make sense to all of people? Dr. Ramakrishna, I think the feedback link will be sent at 3:30, I guess. Yesterday they were mentioning it's going to be like last half an hour or so, right? It should be sent in probably yeah. So yeah, 4:30. I'm sorry. Yeah, it's 4:30. Sorry. Right. So still half an hour. I think they will be posting it in the chat link. So is this concept understood about what AI means, or what ML is, or what deep learning is? Yeah, I hope this is understood, right? So now we will try to specifically deal with this terminology which we are having, which is called as machine learning, right? So when we talk about machine learning, basically what kind of problem statements that we try to solve using machine learning. And before actually getting into it, what is machine learning, right? So can anybody give me a definition of what you understand by this terminology, which is called as machine learning? Anybody? What are your thoughts on it? Understanding data. Machine understands what it is. True. Learn yourself, making the machine to think based on previous data to predict new data. Correct. Ramesh, that's true. How about others? Measuring performance of task from its past experience. Okay. Probably not just trying to understand the performance, but doing something else also. Training model to utilize large amount of data, making machines learn and automate system. Correct, Dipanvita, that's true. What else do you think? Understanding the machine code. Decision making based on available data. Ramya, that's true. Train model using current data and use it to predict new data. Yeah, Himabindu, that's also right. Yeah. So basically, what does machine learning mean is, I want to build a system which has an ability to actually give some sort of decisions on its own based on the previous data that I have shown. Right. So like yesterday, I was trying to explain, I will have some sort of historical data with me, which can be tagged or which cannot be tagged. Right. So tagging is nothing but having a labels for your data. Right. So now if I have some data which is already labeled for me, what I would do is I will take that data to train an algorithm which is done based on the training data that I have shown, right? So I'm not going to say that how it has to learn. I'll only show that data, and the algorithm which is there, that is going to figure out all the possibilities or all the insights, or all the relationships in the data, and it will make decisions for me when there is a new data which is coming in. Does it make sense? Yes, no. Yeah. So that is how it is, right? So now if I want to write a bookish definition for this, how that bookish definition would look like, basically it is a lot of theory over here. If you see, machine learning is an application of AI that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Right. So ML focuses on development of computer programs that can access data and use it to learn for themselves. Right. So now you can see that you can imagine this in a small example that I usually talk about. Right. So now if you see that, imagine this algorithm in certain, like a small boy, right? So there is some a small kid with you and you want to teach that kid about some task. Let's say that you want him to, or you want her to understand what fruits are, right? So in that case, what you would try to do is you would show a specific fruit to that kid and tell what that fruit is. Now, what will the kid do? Probably the kid will touch the fruit, try to taste the fruit, and then try to feel the texture and everything based on the features that the kid is extracting from that fruit. He will keep in mind that this fruit is, for example, apple, or for example, orange, right? So like this, based on the features that he can extract from the fruit, he will be able to figure out what kind of a fruit it is, because I'm actually giving him the feedback saying that what fruit it is, right? So if I show, for example, a 500 or maybe 1,000 examples like that, now the kid will learn it in a better way, right? So he will have enough examples to make sure what is a fruit, or sorry, what is an apple or what is an orange, right? So like this, what we want to do is we want to train an algorithm as well. I want to show as much as data as possible to the algorithm, and that algorithm will try to figure out things. And when there is a new data which is coming in, that algorithm will make a decision for me, right? So now, what are the types of problems that we usually solve using this machine learning, right? So let's say that I have a problem statement, right? So let's say this is some sort of maybe bank domain data, right? So in this bank domain data, I have multiple variables. Let's say I have age of a person. These are all customer 1, customer 2, and so on up to customer n. And I have age of the customer, maybe salary of the customer, maybe transactions done, maybe gender of the customer, location, and so on and so forth. And I want to predict whether customers, whoever are there, are going to take loan from the bank or not, right? So now let's say that this is my target variable, right? So the thing which I'm trying to predict, we call it as target variable, right? So, or it's also called as a dependent variable, right? So target variable, dependent variable, or y variable, these are all same. That means something which I'm trying to predict based on other variables which are over here, right? So how does it look like? It looks like something y which I'm trying to figure out with help of a function which takes in x1, x2, x3 up to xn, which are this. Now age becomes x1 here, salary becomes x2, so on and so forth, right? So which takes in all of these inputs and it tries to predict my y with help of a function which we are trying to give, right? So this is what your machine learning algorithm is trying to do, right? So now I have data with me. That means this data is already labeled. Now I have, for example, 1,000 records, which consists of all of this data, where there is age, there is salary, there is number of transactions, gender, location, and everything. And also I have whether a person has taken loan or not, right? So here, if you see this target variable, which I'm talking about, this is a categorical attribute, because I'm trying to predict whether a person is going to take loan or no, yes or no kind of question, right? So this is called as a classification problem statement, where I am trying to predict certain record whether this is going to fall in this category or this category. Does it make sense, everyone? Yes, no. Right? So now you can see that I am actually trying to predict something with my data that I'm having through an algorithm, right? So when I'm trying to predict a category inside, or when I'm trying to predict a specific category in my Y variable, this kind of problem statement is called as classification problem. Now I can also predict something. For example, let's say that this is not the problem statement that I'm having. That means the target variable is not just yes or no. The target variable is I want to predict how much loan that this person is going to take. Now, when I say how much loan that this person is going to take, what kind of variable it's going to be? Is it going to be categorical or numerical? Numerical, right? So exactly. When I am trying to predict a number, right? So when your target variable is a numerical attribute, then this kind of problem statements are called as regression problem statements, right? First thing that we all have to understand is machine learning is nothing but trying to make sure that I teach something to an algorithm or to a system with my algorithm. Once I know what machine learning is, there are again two things. One, we call it as a supervised machine learning. Other one, we call it as unsupervised machine learning. What is supervised machine learning? If in my data, if there is a target variable existing, that means I know if there is something that I need to predict. It might be numerical or it might be categorical. But if I know if I have a variable which has to be predicted, that means if I have a target attribute with me, then it is supervised machine learning. And if I don't have target attribute with me, then it is called as unsupervised machine learning. Right? So in supervised machine learning, there are two things again. One, it is called as classification. Other thing, it is called as a regression. When it is called as classification, when I have a target attribute which is categorical in nature, then it is called as a classification problem. Right? So this category may be even 3-4 categories. Right? So here I have given an example only of binary class classification problem. If I have 3 categories, for example, I'm trying to predict low, medium, high. There are 3 categories. This will come into multi-class classification problem statement. Right? So this falls under classification. Next is if I have a target variable which is numerical, that means I need to predict a number. For example, I want to predict what is the amount of loan that a person is subscribing to, right? Or what is the revenue that a person is generating. All of these things where I'm trying to predict a number will come into a category called as regression. This is a regression kind of problem. Are we all clear over here? Do we have any questions? Yeah. So all of this, right? So for example, if this is a medical domain problem and I'm trying to predict whether a person, yeah, Dr. Deepak, I'll talk about regression again. Don't worry. Right. So now let's say that it's a medical domain problem. I'm trying to predict whether a person is having cancer or no cancer, or having disease or no disease. Right. So there, my target variable is a classification. Basically, my target variable is a categorical attribute. Hence, that becomes a classification problem statement. Right. When I would say regression, whenever my target variable is numerical in nature, then it becomes a regression problem. That means, for example, I want to predict sales. Right? I'm trying to predict number of, for example, number of products sold or number of products that will be sold in next quarter. Right? So there I'm trying to predict number. Hence, this becomes a regression problem. Can we regress a panel data? If yes, then how? Dr. Debadatta, can you explain me like what do you mean by panel data? Is it economic data or something like that? Yeah. So time series data, again, as I said, time series data is again kind of regression. There will be there you will not follow the normal linear regression or your other machine learning algorithms. Again, we will get into something called as time series methodology there. right? So where we do this auto regression component, and then we'll try to build ARIMA models and all that, right? So that is something which is kind of a parallel to what we are doing in regression problem. The concepts again will be kind of regression that we are taking, but not exactly like how we build our linear regression models, if it makes sense. Yeah. So this was about the high level overview of machine learning algorithms, right? So how or what kind of problems that we solve, right? So there is one more link or one more category which we haven't touched, which is your unsupervised machine learning algorithms, right? So what are unsupervised machine learning? Problem statement: when I don't have my target attribute, that means I only have variables with me. Yes, Dr. Rahul, reinforcement learning is also kind of a segment that people talk about, but it's completely a different concept to learn, right? So there will be something called as environment, and then we are going to teach a agent there, right? And then based on whether it has taken the right path or wrong path, we are going to give some reward, right? So that's completely a different setup, I would say. Yeah. So in unsupervised machine learning, what actually happens is we don't have our target attribute, right? So target is not present. We only have our variables. That means I only have my independent variables, right? So for example, I only have age, maybe salary, right? So maybe, let's say place from where it's coming, maybe some other x4, x5, x6 up to xn, right? So now what we want to do is we want to bring in some algorithms and try to probably cluster these kinds of records which are similar in nature, right? So all similar records. For example, if I define that maybe I want 3 clusters. So clusters are nothing but groups of data, right? So because we don't have our Y attributes, so we just want to do some sort of segmentation on our data, right? So all similar records which will be there in cluster 1, all similar records will be in cluster 2, or all similar data will be in cluster 3, and so on and so forth. And based on the data that we have in cluster 1, we are going to analyze the data and see what would be the pattern of that data and take right steps, right? So those kinds of problems come under something called as unsupervised machine learning. And there is one more thing which is called as association rules, right? So where we try to generate some sort of rules based on similarities again, right? So there are again other algorithms which come into picture, right? So where we try to generate some sort of rules, we call it as association rules. But our focus for these 4 or these 3 days will be in the side of this, which is supervised machine learning, right? So where we have labels with us and then we try to build models, right? So does it make sense to everybody? Now everybody understands what is actually machine learning means, what is a classification problem statement, what is a regression problem statement. Any questions or any comments that people have? Can you repeat association, right? So what we usually do is, let's say that association rules or association is basically, this is again a section which we talk about in something called as market basket analysis, right? So what we do over here is we try to get all this usually runs on transactional data, right? So even in that data, we don't have our Y attribute, right? So we don't have our target attributes. So here what we do is we try to build some sort of, so there is an algorithm called as a priori, right? So whenever you have some time, just try to Google this a priori algorithm, which is related to market basket analysis. What it will do is it will give me certain rules about my data, right? So for example, let's say that transaction 1 is happened, and in that transaction 1, probably somebody has bought bread, somebody has bought milk, right? So let's say that this is a retail data. Somebody has bought eggs. right? So maybe there is some next transaction that has happened. In that, people have bought maybe some sort of clothes, right? And then maybe diapers, etc. And then there is one more transaction which is actually happening. And then there is all of these kinds of transactions, right? So what does this a priori algorithm does is, here also we don't have our y attribute, right? So it will try to generate frequent item sets. It's called as a frequent item sets, and it is going to give me some sort of rules and tell me what are the items which are brought frequently, right? So maybe there is something which is very, very say that not familiar to me at all, right? So there is usually people talk about the beer and diaper example, right? So in US, there was a research or survey that they had done, that they saw that on every Friday, people bought beer and diapers together, right? And the sales of beers and diaper was really high in US, right? So, and then they figured out that, okay, probably it's a weekend, and if the father is actually trying to do some sort of shopping and he's trying to buy diapers also, and then he's buying beer also for the weekend, and so on and so forth, right? So these kinds of insights came into picture, right? So these are the kinds of patterns which we want to actually find out in our data. Now, when I find out these kind of patterns, I might want to take multiple business actions, right? So while I'm actually placing all my products in the aisle, I can say that, okay, when I know people who are buying beer are also buying diapers, then what I would do is, maybe at the starting only I'll keep all the beers, and at the end I would probably say that I'll keep diapers, right? So person who has bought this will have to walk completely all the aisles and then buy diaper, right? So in this walkway, probably he might pick up some more things also, which will increase my number of items to be sold, right? So this is one small applications about association rule, right? So basically, association rules are nothing but trying to come up with the patterns or the rules patterns from your transactional data, right? Does it make sense? Yeah, awesome. So yeah, so this was about your machine learning. And yeah, somebody asked some question. Let me just go back to the thing. Yeah, I think I have addressed all the questions. So please do type questions again, guys, if I have forgot, or if I have just couldn't answer or skipped any question, because I'm getting a lot of messages over here. So maybe there is a chance that I might actually miss some things. Madhav, again, clustering means kind of segmentation. That's true. We are trying to put all the similar records in multiple clusters, right? And then come up and then see like what patterns those clusters are following. Right? So this is again your unsupervised learning. Yeah. So the next thing that I wanted to go with today is basically called as linear regression, right? So now, as you can see here, linear regression is one of the most common algorithms, or a common yeah, let's say that let's call it as an algorithm only, right? So a common method that people usually use when you want to predict a numerical attribute. That means I will use linear regression as a base algorithm when I have my target attribute as a regression, or I have as a numerical attribute, right? So for example, again, let me repeat, right? So let's say like, what are the regression kinds of problems that we discussed about? For example, I want to predict, let's say number of units sold, right? So here you can see that I'm trying to predict a number, right? So I'm trying to predict temperature, for example. I'm trying to predict maybe number of people who are going to attend this class tomorrow, right? So maybe I'm trying to predict number of, let's say, the amount that is going to be generated, right? So revenue of people in retail store, for example, right? So all of these things, wherever I am trying to predict a number, this is called as linear regression, or this is called as a regression problem. And in regression problems, we have an algorithm which is very, very basic that people should know, is called as a linear regression, right? So here what we try to do is we try to establish a relationship between your X variables and Y variables and then come up with a curve or a line, right? So let's say that I have a problem statement and I want to predict something, right? So let's say I want to predict the price of used cars. Let's say there is a startup or maybe there is some sort of a idea that people are thinking about, which is trying to predict price of a used car for people, right? So they have built some sort of a website and they're asking some parameters. You put those parameters in that website and they are going to give you what is the expected price that you can sell your car in the market. Does this problem statement make sense to everyone? Yeah, right. So now let's say that what might be the variables that are important for me to predict the price of the car? What can be the variables that I can think of? Brand of the car, very important. Agree. What else? Usage, time of usage. Let's say the age of the car. How many years did he use it, right? So let's say number of kilometers that he has run the car. What is the mileage of the car, right? So fuel type of the car, exactly, right? So all of these, whether this is petrol or diesel or whatever gasoline, right? So model of the car, all of these variables will be helpful for me to predict the price of the car, which is Y variable over here, correct? So now what we want to understand is we want to come up with some sort of an equation which tells me the importance of each and every variable in that equation. And when I input the input values, which are of these variables in that equation, it is going to give me the price of the car, right? So now let's simplify this problem statement with only one variable. Let's say that I only have age of the car. Now, with the help of age, can I predict price of the car? Can I do this? Can age be a very important variable to predict the price of the car? Everybody agrees on this? Yeah, right. So this can be one very important variable. Now let's say that I have two variables. One is X and one is Y, right? So now let's say X is age of the car and Y is price of the car. And I have some historical data with me. I have done survey. I have done a lot of work behind and I have collected some data. Let's say that, okay, when I have ages of the car, let's say this is 3 years old, this is 5 years old, this is 2 years old, this is 10 years old, this is maybe again 3 years. Let's say 3 already have. Let's say that this is 6 years old, right? So and the price of the car is maybe, let's say this is $8,000. This is maybe $4,000, right? So and this is maybe $9,000, and this is probably again $2,000, and this is again $5,000. Let's say this is the data that I have collected, right? So now when I have this kind of data, can I actually draw some sort of a scatter plot to understand the relationship between age and price? Right? So what does a scatter plot mean? Scatter plot is this, which we have over here. Here we only have 3 dimensions and I have reduced it to only 2 dimensions, right? So if I want to draw a scatter plot, how does that look like? It will look something like this, right? So I will have my Y variable, my X variable. Y is nothing but price over here. X will be your age of the car, right? So maybe age is 1, 2, 3, 4, 5, 6, 7 up to 10, right? And then I have my prices, maybe 1,000, 2,000, 3,000, so on and so forth. And then I have all the data that I have just plotted. Right? So let's say that this is how my data looks like. Now, based on this scatter plot, will I be able to understand if there is some relationship between Y and X? Okay, if yes, what kind of relationship do you see? Yeah, there is a slope, correct? Right. So if there is a slope existing, then there is a relationship between these two variables. right? So at the end of the day, what I'm trying to do is I am trying to find out that slope only. That slope is actually a representative of the relationship of age with respect to price for me. Do you all agree on that? Agree, right? So now let's say that there is some sort of a relationship that everybody agrees now. Also, people are saying that there is some sort of an inverse proportionality, right? So there is some sort of a relationship with respect to X and Y, where when age is increasing, Y is decreasing. Do you all agree on this? Right. So this is called as correlation. When I'm trying to understand a relationship between two variables, this terminology, which is correlation, that is important, right? So it tells me the relationship between two variables. And I can calculate the correlation between two variables with a formula also. I'll not get into the formula right now. Let's understand the concept first, right? And this correlation will be existing between -1 to +1. Right? So now, as you can see, the slope over here, is it negative or positive? It is negative. Everybody agrees. As one is increasing, the other decreases. That means there is a negative slope, right? So this is called as negative correlation, right? The strength of a relationship between your X and Y is defined by correlation. And in this correlation, we come up with a number. If a correlationship between two variables is higher on a negative side, we call that it is a strong negative correlation, right? So for example, let's say the correlation between these two variables I got is -0.9. This is saying that there is a high negative correlation between your X and Y, right? So this was about your negative correlation. Can anybody talk about a positive correlation? Can you talk about any example about positive correlation? Income and tax. Oh man, that's very true. Land cost, that's also true, right? So let's say that age versus cost, and this is for land, right? So in 2000, what was the cost of that same land? In 2001, what was the cost of the same land? In 2, what was the cost of the same land? 3, what was the cost of the same land? And so on and so forth, right? So now if this is the case, now can we say that when one is increasing, let's say that when Y is increasing, or let's say that when X is increasing, Y is also increasing? Right? So if I want to draw a scatter plot, will it look something like this? Right? So there is a direct correlation. That means my correlationship will be positive in nature. Let's say that maybe I have calculated the correlation and I have got 0.8. Right? So this is a strong positive correlation. Earlier was a strong negative correlation, right? So when we talk about this correlationship, it is actually talking about the direction and also about the strength of the relationship, right? So positive or negative will give me the direction, and the number would give me the strength of the direction, or sorry, the strength of the relationship, right? So this is how I want to understand the relationship between my X and Y. Now, let's say that if I try to draw a line when I have two of these variables, now can I come up with an equation for this line? Yeah. Now let's say that the equation for this line is, let's say, y equals to beta naught plus beta 1 x1. Right? Yeah, y is equals to mx plus c. That's the right equation also we are talking about. Right? So now, if I am able to find out these two parameters, which is beta naught and beta 1, with some methodology, let's say that there is one methodology called as OLS, ordinary least square method, right? So I'll come up with that methodology and I will try to find out what is beta naught and what is beta 1, right? And if I have found out these two, right? So what is the beta 1? Basically slope that I'm trying to find out. Beta naught is your intercept value that I'm trying to find out, which is this value. When I have found out these two values, now will I be able to calculate the future? That means if there is a new customer that is coming to me saying that the age of the land is maybe 10 years old, will I be able to predict the price of that land? Can I predict the price of the land if I have age of the land when I have figured out these two parameters, which is beta naught and beta 1? It's going to be simple, right? Yes, no. Madhav says no. So what I'm saying is, Madhav, I am going to find out my beta naught. Let's say that I have got beta naught, right? And then I have my beta 1, right? So when I have these two parameters, my question over here is, when there is a new customer walking in with X1 as an input, will I be able to find out my Y or not? Right. So simple, right? So you will be able to find out your unknown because you know a value and you know the parameters also, right? So this is called as a simple linear regression. Right? So trying to figure out the equation of the line and putting some unknown values and trying to predict those things, right? So this is called as a simple linear regression. Why this is called as simple linear regression? Because my independent variable that I am talking about is only one over here. That means I only have one independent variable, which I'm taking use of to predict my dependent variable, which is land cost. If I extend this problem a little bit, for example, if I not only age, if I add a location also, right? Maybe if I add in which, let's say, layout that I had have this land, right? So all of these are multiple informations that I'm actually adding in. What will this equation become then when I have multiple variables? Right? So this equation can be actually extended. I'll say y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 up to beta n xn. Right? So this became a multiple linear regression. Right? So when I had only one variable, I call this as a simple linear regression. And when I have multiple variables that I have in input, then I call it as multiple linear regression. Are we all clear with this concept of regression, linear regression? Or do we have any questions or any doubts? Right. So how do I find the line and how do I find the M's and everything? We will talk about it a bit later. But on a high level, this is the concept, right? So I want to actually understand the relationship between my dependent variables and my independent variables. And then I will come up with an equation where I will find out those unknowns, which are slopes for each and every variable, and then predict whatever was the unknown. Right? So now let's say thank you for the compliments, everyone. Jagdish, Usha, Dr. Usha, everyone. Thank you. Jagdish says, sir, for large data set, it couldn't provide best solution. Yeah, that's true, right? So this is only a linear regression, right, Jagdish? Right? So you will be able to find any solution only in a linear plane here. That is the problem. Right. So when I try to make my algorithm complex, this should be able to figure out even better solutions. Right. So maybe linear regression is not the best suited algorithm for the problem statement that you are working for. Maybe. right? So in such cases, maybe I'll use a little bit more complicated, maybe like neural nets, or I'll use some sort of other SVMs or random forests, right? So in that case, what happens is you will be able to figure out even in that multiple spaces also. Or else I'll do a lot of transformations on my data itself and then build a linear regression. That should give you a better solution as well, right? So you can have multiple ways to find out better solutions. Okay. Yeah. So this was about a very high level understanding on what linear regression means, right? So now let's go through the actual content that I had, right? So basically I did not get into the actual content only. I started explaining everything without any slides here. But as you can see, what is regression, why regression, scatter plot, measures of association, what is correlation coefficient, how do I fit a line or a regression line? We'll talk about all of these things. Regression problem. Dr. Ritesh, we will take this question in tomorrow's class. Please do remind me about this question, which you are saying, which algorithm to take to solve regression problem. We will. I'm pretty sure that I'll be able to convince you in tomorrow's class, because we will see one more algorithm tomorrow. We'll talk about that also. Yeah. Right. So these are all the things that we are going to figure out. Right. So now, as you can see, we know what regression is. Regression analysis plus correlation predict future performance using past results, right? So I have some past results. I want to draw some sort of a line on it, or I want to do some curve fitting on it, and I will have the equation of that curve, and then I will say that I will predict the what you call unknown data for you, right? So while correlation explains the degree of linear relationship that exists between two variables, regression defines the relationship more precisely, right? So your correlation was only giving you some intensity, right? So it was only giving you some strength and probably the direction between the two variables. But when you do the regression, you will be able to also predict some unknown values as well, right? So that is what this line says. Regression analysis is a tool that uses data on relevant variables to develop a prediction equation or model. It generates an equation to describe the statistical relationship between one or more predictors and response variables, and predict new observations, right? So here you can see some new terminology: predictors, response variable, and all. These are all nothing but your dependent and independent variables only, right? So predictor is your independent variable. Response variable is your dependent variable, which is your y variable over here. Yeah. So let's go a little bit further and then try to see how I will be able to let's say how I will be able to get the best line fit, right? So this is all the same thing that I talked about, right? So I have some variable which is used car, and I have some variable which is miles driven, and beta 1 is something, and there would be an error while you are predicting, of course, right? So that is accounted for this epsilon over here, but the equation is the same: y is equals to beta naught plus beta 1 x plus your epsilon. Epsilon is some hidden error or noise that you're having in your data, which is always accounted for your predictions. Right. So here you see two variables. One is experience, the other one is salary. Right. So now with our assumptions, or with our knowledge that we are having, what kind of relationship between exists between these two variables? Is it positive correlation, negative correlation, no correlation? What do you think? Positive correlation. A lot of people are saying it's going to be positive correlation. Right. So, and it's ideally true also, right? So most of the times you can see that when there is a lot of experience on the with the people, companies usually tend to pay more, right? So for his experience, for problem solving and all that stuff, right? So when I try to draw a scatter plot with these two, how does it look like? It looked something like this, right? So you can see that I have my X and I have my Y, and you can see that there is a positive correlation, or you can see that it is the curve, the slope that you can get it from the line which you draw is going to be positive, right? So this is how your what you call regression line will look like. Now my question over here is, I have the data with me, right? So now this is some line which is already there, right? So let's say that this is M1 or S1, which is solution 1, right? So let's say that this is solution 1. I will draw one more line, which is very close to this. And I'll call this as solution 2. And I'll draw one more line, which is an yellow line, something like this, and say solution 3, right? So now you tell me, which is the best line to fit? And why do you think that is the best line? Is S1 good, S2 good, or S3 good? Which one is the best line? People are saying it is S3, S1, low data, 1 good. Okay. S1, S3. There are a lot of people who are directly jumping to the solutions over here. High data, another. Right. So now you can also say that I can draw 10 more lines. Do you agree? I can draw 10 more lines, 20 more lines. I can draw 100 more lines, which are very, very close. Right. So if I can draw so many solutions, how would I pick? There should be some criteria to pick the best line, right? Do you all agree on that? Yeah, by finding the distance of each point minimum to the distance to choose, line that touches most number of points. Yeah, there are a lot of correct answers over here. I would say that I will actually come up with some sort of a solution where I can find out the values, or where I can find out the differences between the actual data and predicted data, right? So now let's say that, let me clear all the lines. Let's say that there was some solution here. You can see that at 4 years experience, somebody is saying that around 60, 70, right? So let's say that $70,000 was something which was actual. But what my model predicted? My model predicted it to be 60. Do you all agree? If my model actual value, let's say that Y actual that I have predicted is 60. No, Y actual is 70 and YP, which is Y predicted, is 60. Only with this example that I'm talking about. Do you see there is some difference between actual and predicted? Everyone? Right. Now there is a difference of 10 in between them, right? So now, can I calculate the difference? That means now I can say that this is the error that my model has made in prediction, which is 10 units. Let's say I'll call them as units. Now, can I actually calculate the error which is made on each and every point with my model? Yeah. So now let's say that my error is summation of your Y actual and Y predicted. Right. So basically, the difference between your Y actual and Y predicted is the error that my model is making. Do you all agree? And when I do a summation of it, it gives me the total error that my model is doing. Right. So now what I want to say is, I will pick a model where my error is minimum. Does it make sense to everybody? I can draw n number of lines, but in those n number of lines, there will be one line which will have least error. Agrees? Right. So then that is called as a best fit line. Right. So I am going to take that line as a best fit line when a line which actually makes less error or minimum error or zero error. Zero error is practically not possible, but let's say that the line which is making minimum error is called as a best fit line. Right. So that is how I set up my criteria. And this is also sometimes called as a loss function, or you can call it as an error function or a cost function. People come up with multiple terminology for that. And then I'm going to try to reduce this error as much as possible. And when my error will not reduce at all, whatever the line I'm left with, I'm going to pick up that line. So this is how you are going to select the best fit line. Does it make sense to everybody? How much error is allowed? Again, Kavita, that is again a very subjective question. Because you will be, this is all again experimentation that we talk about, right? So we will get into error metrics, right? So now this percentage is very subjective term. How will I know how much percent it is, right? So this is all again in units. So that's the reason what we talk about is there is a terminology, or you can say that there is a metric called as R squared that we will talk about. Right. So if time permits today itself or tomorrow, probably we will talk about this R squared. This R squared is some measurement or some metric which will tell me how much of variance that I have in Y is explained by my X. Right. So if my model was perfect, or if my model was absolutely awesome, then everything which was in Y should have been explained by my X. Do you agree? Right? So if my R squared is 100%, then I would say that my model is perfect. But ideally, you will not get any model on practical examples where your R square is 100. If your R square is 100, then probably somewhere some mistake you are doing for sure. Right? So then you will say that, okay, whatever is closer to 100, whichever the model that I have got closer to 100, then I will pick up that. That is how you are going to select your model. Right? So I hope this clears that doubt. Right? So this is how you are going to select the best fit line. And there are a lot of formula to find out which best fit line and all. Right? So now you can see here, there is something called as total sum of squared. Total sum of squared is regression sum of squared plus error sum of squares. We will talk about this. Can we set confidence level to get maximum R squared? Maximum R squared in the sense you will not have usually any confidence level to it. You will have confidence level to the importances of each and every variable, which we call it as p values. But for R squared, it is going to be a number. There wouldn't be any confidence level to it. Right. So these are some terminologies. I'll not get into this right now. We'll talk about this when it is really required, because it's going to eat a lot of time, right? But the concept here is going to remain same, right? So, and as I said, this is the R squared, right? So R squared is nothing but how much of a variation is being explained out of total variation from my X, right? So ideally, if my X was able to give you 100% information about my Y, then that means my model is 100% right. Do you all agree on that? If my question here is, if the variation in Y is being explained by X, which is 100%, that means everything that I could have extracted from X to predict Y is being extracted. Do you agree? Right. So that is what your ratio here also says. SSR is nothing but sum of squared regression. That is how much of variance that is being explained by the model. Sum of squared regression means. And what is SST? SST is sum of squared total. That means total variation that is available in your Y. Right. So that ratio is given by your R squared. And this R squared will be between 0 to 1 or 0 to 100, whichever way you want, you can see it. Right. And if your R squared is closer to 1, then that means that you have built a very good model. If your R squared is very, very less, then probably you might want to add more data, or maybe add much more important variables, or maybe you want to go with some more transformations of the data, and so on and so forth. Does it make sense to everyone? Right. So this is how we actually try to build our model, right? So apart from these R squared evaluation metric, we have multiple evaluation metrics to see how our data is doing or how our model is doing. One, we call it as RMSE, which is root mean squared. SSR is sum of squared regression. SST is sum of squared total. Right. And then RMSE is root mean squared error, MAP is mean absolute percentage error, MSE is mean squared error, MAE is mean absolute error. Again, these are all the formula basically where we want to see, once we have built our model, how our model is doing. These are all the evaluation metrics we will look into, right? So when we implement our model, probably tomorrow, we have already closed the time today. Tomorrow we'll try to implement a model on Python. We'll try to calculate our R squared and then see how our model is doing. Right. So with one variable, how it was doing, when I'm adding many more variables, how the model is doing. We'll look into all of those things in tomorrow's class. Right. So if I get into the code right now, I will not be able to complete it because it's going to take some time. So I'll try to finish that in tomorrow, first half an hour, and then we'll move to the second algorithm. Right. So yeah, guys, so this is what I had planned for today. And I also had planned actually to cover some coding part also, which we will cover in tomorrow's class. Right. So I hope the concepts are clear today. Thank you, Kavita. So any questions or any doubts or any comments that you guys have? Simple, clear, crystal. Thank you. Thanks, Madhav. Thanks, Dr. Brahma. Thank you, Venkateshwarlu. Thank you, Dr. Jagdish. Thanks, Dipanvita. Thank you, Ritesh. Yeah, so tomorrow topic, what we will do is I will try to cover this code in the first half an hour. And then there was a request that was to cover about decision trees and random forest. Right, so these are the two algorithms again, which I will be covering in tomorrow's class, which is decision tree and random forest. That's going to be very interesting, right? So we will try to implement a classification problem statement tomorrow. So today we looked into a regression problem. Tomorrow we'll look into a classification problem statement and then cover it. Thank you, Aruna. Okay, I would request everybody again to give your feedbacks, guys. Amar has posted the link in the chat. Just please do finish that feedback form as well, which is again going to be helpful for us to evaluate ourselves. Yeah, so Amar, do you have anything to share with the team?
No, nothing. You covered that regarding to the attendance.
Yeah, awesome. Okay, then thank you.
Team, if you have any query or question, so please drop on edl@excelr.com. I'm sharing that mail ID.
Sure. Thank you, Dr. Nilma. Yeah, so this edl@excelr.com email ID Amar has shared, guys. Please do share if you have any questions or any doubts. And also the PPT that I have covered today, all of those PPT, you will be able to find it in LMS portal. Please do find that and see if you have any questions in tomorrow, we can still discuss. Okay, then thank you guys. That's it for the day today. Let's meet tomorrow, same time at 3 o'clock. And then we will try to cover some more important concepts in ML. Ramesh, I would suggest if you have installation of Python already or Jupyter Notebook already in your system, that is well and good. If you don't have, then also it's not a problem because you can still load in your data in your Colab. Which is coming from your Google account. You can try to write code there as well, right? So, but what I'll do is I'll do some live coding tomorrow, and I'll request you all guys to observe the code and see if you have any questions or any doubts. We can talk about it, and after that, I will share that code with you in LMS once it is done, right? And then probably you can practice it when you have some time. Amar, can you see if you can share the LMS link with the class?
Yeah, sure.
Yeah, thank you.
One time share.
Yeah, so onlinelearning.excelr.com. This is the link, guys, where you can find all the material. Please do log in into that and then try to find out the material. Okay, then. Thank you, guys. Thanks for joining. Let's meet tomorrow. Signing off for today. Thank you. Bye-bye.
Okay, thank you so much all of you for joining the sessions. So we'll meet you on tomorrow at same time, 3 o'clock. Okay, bye. Have a nice time.